Hi everyone. So in this video session, I'm just going to discuss one of the very useful and important concept called proof by contradiction, right? So if any theorem is given and if any theorem or a statement you have to prove, okay, so you can prove it by contradiction. So I think every computer science Fox uh, talks about that very important example they take and prove it, okay. So I'm also just going to do the same, right? And I will explain you what is the meaning of proof by contradiction, right? So as a part of mathematics for computer science initiative taken by EECS Academy for all the computer science people as well as for all other branches, those who are preparing for GATE computer science and data science and AI. So you need to understand these concepts, right? So in this video, I'm just going to explain you what is the meaning of proof by contradiction. Okay, contradiction. So you can solve many problems, by this concept. In fact, solve by contradiction also you can do. You might have seen one of the video that I have uploaded on this YouTube channel, right? How to solve something, one of the linear algebra question by contradiction. So now we will understand what is this proof by contradiction. So I'm just going to take one of the very important problem that was also asked to me from many interviewer, right? Whenever I used to give my interviews, so they used to ask question like what was the question. I'm just going to tell you the question here. Can you prove that root 2 is irrational? Okay, can you prove that root 2 is irrational? Okay, so many of us do not know about it. Okay, we don't care about, in fact we don't bother about, okay, how. We just know that root 2 is irrational, that's it. Okay, but we don't bother about how to prove it. Okay, but at times you need to understand if you are from computer science graduate, or you can say if you like mathematics, okay, and you are making your life, you are thinking that you want to build your career in mathematics and computer science, okay, so you need to know all these kind of concepts, because they will help you in problem solving, right? Because at the end of the day you have to solve problem of the world, right? Some of the interesting problem and challenging problem of the world, right? So at EECS Academy, uh, we are emphasizing on mathematics, okay, heavily, okay, in India. So this example I'm just going to prove you, and after watching this video, uh, proof by contradiction will be certainly clear in your mind, right? So root 2 is an irrational, okay. So what we are going to do here is we are going to start with the assumption here, opposite assumption you can say. I'm just going to make assumption that this root 2 is rational number, and we know that if the number is a rational number, right, if any number is a rational number, that can be written as ratio of two integers, okay, and those two integers must not have any sort of common factor in it, right? I mean, they must be written in standard form, right? Okay, this is a class 8 definition you can say, right? So if you have to start this, okay, so if I start solving this root 2 is irrational, so you have to assume that, or you have to suppose, right? Suppose root 2 is rational, okay, this is your starting point. Okay, if the number is rational number, you must be able to write that number as p by q format, and p and q are nothing but the integers, okay, and and you have to ensure that the denominator must not be equal to 0, okay, and they must be written in simplest form, or you can say the standard form of the rational number. What is the meaning of standard form of the rational number? Nothing should be common, only the common factor which should be there is 1, right? And nothing, no prime factor, no any prime factor must be common, right? So I must be able to write this root 2 as, you can say that, numerator by denominator, right? Like n, where n and d are integers, okay, where n and d are integers without, you can say, without any common, okay, common prime factor okay, without any common prime factor such as 2, 3, or whatever, without any common factor, you can say only one is going to be the common, right, between n and d, right? So if you take the gcd of input, numerator and denominator, so you must get 1. Gcd must be always 1, right? So root 2 is here, the root 2 has been written as n by d, right? So let us move ahead, okay? Okay, so this is my assumption, guys, okay? And if we are going to, move ahead, right, step by step, okay? So we will find that at one point of time, this assumption is going to be contradicted, okay? That is called proof by contradiction, right? So certainly in some steps as we move ahead, we are going to, we are going to face the contradiction. So let us move ahead. So what is the next step that you think you should go ahead? Root 2 equal to n by d. So what further you can do? I'm pretty sure that you're going to multiply d both sides, right? So if you multiply d both sides, okay, so it is going to be written as root 2d equal to n. So if you want to remove this square root, so what you will do here is squaring both sides, right? So 2d square equal to n square. Understand? 2d square equal to n square, guys. Now you know that if any number is given, right, if any number is given, suppose d square is here, right, and if it is multiple of 2, right, so this n square is going to be what? This n square is going to be the even number, right? So from here you can say that, from here what you will say, that this n square is equal to what? 2d square. Okay, n square is nothing but 2d square. What does it imply, right? It implies that this n square is even, okay, since it is equal to 2 times of the d square, okay. I hope this makes sense, and which is an integer, understand? So if n square is in even, you can say that n square is even, then n is also even, okay. Now how I said that n is also even? From the basic arithmetic, okay. From the basic arithmetic you can say that if n square is even, then n is also even, okay, if n is also even, fine. So if n is even, if n is even, certainly if n is even, so what you can do here is you can choose n equal to 2 times k, because you know that if any number is even, so you can write them as multiple of 2, right? So n is equal to 2k, right? So you can take the square of both side again, so it is n square equal to 4k square, right? Why I have taken square of both the side here? So that you can plug in place of n square this 4k square, right? So that we can also prove that, okay. So let us plug here first. So 2d square equal to, now it becomes 4k square. So from here you can say that if you cancel 2, okay, so it is nothing but 2k square. So from here also you can say that this d square is even. If d square is even, so d is also even, okay. D is also even, right? And if d is even, so in the beginning what was our assumption was कि root 2 can be written as n by d, where n and d are integers without any prime common prime factors. But here if n and d are even numbers, so certainly there will be what? There will be something common, that is nothing but 2. So my assumption is now contradicted, right? There is some contradiction lies inside this manipulation, right? Okay. So what we can conclude here is that the conclusion is going to be root 2 is irrational number. Okay, because of this contradiction, okay. I hope this makes sense, right? So you can say that because of this contradiction, understand? So we have seen what both p and q are even, right? What is the meaning of that? They have common factor of 2. Okay. So this contradicts the original assumption that n by d, that n by d is what, guys? N by d. Okay, here n by d is going to be, okay, n by d is what? You can say that n by d was in its standard form, right? So this is a contradiction, because initially we said that you can take n and q, n and p as q also. In place of n by d, you can also write p by q. No problem. Okay. You can take A by B also. So initially my assumption was, what was assumption? N by D is in its simplest form. But since N and D are even number, this contradicts, right, our assumption. Okay, so you can say that root 2 is irrational, because if something is not rational, so you can say that root 2 is gonna be irrational. So I hope this video you might have liked it. Okay, so please remember, okay, please remember, understand, so you can always do you can always prove something by contradiction. So this is a proof by contradiction topic, and I will be bringing all entire discrete mathematics, entire maths which is required for computer science, okay, computer science Fox, and for data structure to understand, algorithm to understand, whatever mathematics is required for entire computer science, group, okay, that I'm gonna bring at ECS Academy. So thank you, keep watching our content, okay, and we'll meet in the next video session. Thank you.